Hello, students. My name is Sonia Malik. I'm your coding teacher and mentor. So, in this video, you will be seeing how, for various return types, the functions are called inside main and what is function prototyping, right? All the best. Thank you. Hello, students. Today we will be discussing function prototyping in C++. Yes, you heard it right. Function prototyping in C++ language. Okay. Suppose I have to create a function to add two numbers. So how will I do that? Void function name is addition open round braces. I already explained you this in previous sessions. That's why not telling you what is this, what is that, right? I'm just writing the function, right? It is taking two parameters from main function and it is doing like this, a plus b. And main function is declaring and initializing this variable. Int a is equal to 10, int b is equal to 20, and calling this function addition in itself and passing this values, right? Main is giving this values of a and b to addition function, so that addition function can take those values as a formal arguments and then do an addition operation, right? A plus b. This is what we have learned in the previous video. But I want to tell you one more thing, that it depends on the return type how the function will be called. I again repeat, it depends upon the return type how the function will be called in main. Okay. Suppose this is a void function, so it is not returning anything. It is just printing cout a plus b. That's why we simply called this function by writing the function name. But suppose there is an integer data type of this function and this function is not printing but returning a plus b. Return a plus b, right? This function is integer data type which is returning an integer value of 10 plus 20, that is 30. So you cannot simply call this addition function like that. Okay, you cannot call this addition function like that. How will you call this addition function? You know that this addition function is returning something, that is 30. So you will collect what is returned by this addition function in some variable. So how will you collect it? Int, let us say answer equals to, do you know like what I have done by this? This addition function will return some integer value of 10 plus 30, 20, that is 30. 30 is an integer and I have collected this 30 in an integer data type with answer variable. Okay, this 30 returned by this function addition, I have collected this value 30 with answer variable in answer variable in answer variable. That's why int answer is equal to addition. Now we can easily print that answer. We can easily print that answer. Let us run this code. Let us run this code. What we will get? Oh, it is taking some time. Okay, it is printing us 30, right? Okay, suppose if there is a string data type. Let us say there is a string. So can you tell like what changes will you do? You will return a string. Suppose you will return a current. You will return current, right? Like this. Okay, you have returned a string. In what variable, in what data type it is getting collected? As you can see, your addition function is returning a string. So you will use a string data type to collect that value. That's why string answer variable, and you have collected your string current in some answer variable, and that you have printed. Suppose there is a character data type, character return type of the function. Character return type. Suppose you're returning some character like P. Suppose you're returning P. In what data type you will collect that P? In character data type. With what variable? Answer variable. Okay. So when you have a void function, there is no need to store that value because it is not returning anything. But this addition function is returning a character. It is returning a character. It is returning a character. That's why you store in some character variable. You have to store it. You have to catch it. Like this addition function is throwing character P at you and you have to catch it. Like for catching purpose, you need some variable now. You need some bucket. When someone is throwing a ball, you fold your hands or you collect it in a bucket, right? This is a bucket, this is a variable bucket which collects the character p thrown by this addition function, right? Thrown by this addition function in the character data type. Okay, suppose this is returning a float value, this is throwing at you some 3.5, it is throwing a 3.5 at you. This addition function throws a 3.5 float value at you, and you will collect this in answer variable with the data type float. Okay, and then print it. So this is, I have shown you what return type value you will collect, you like with what return type value you will call function in what way, right? Okay, I hope you're clear. Like void function is called how, integer function you will call how, float function how, okay, string function you will call how, character function how you will call. So there are some methods to call that function. With void you can simply write function name and pass the parameters. But the functions that are returning something, like float is returning float, character is returning character, integer is returning integer, string is returning string. So those functions that are throwing some value at you, that are returning something to you, you have to catch them in some variable and then print that variable. Not simply writing function name, but catching that some in some variable and then printing that variable. Okay, I hope this thing is clear to you. Now let's move to the topic function prototyping. Now let's move to the topic function prototyping. Okay, so what is function prototyping like? Okay, so what is function prototyping? Let us quickly discuss it up. Okay, generally let us write a simple function, let us write a simple function, int function, right? Okay, suppose this is an integer function that is doing the addition operation of two variables a and b. Suppose it is returning a plus b and it is a integer data type, right? Return type. Or okay, this is a simple thing that you have learned previously also. Okay, I told you that most of the functions are declared above this main function. Most of the functions are declared above this main function. Above this main function. But some functions can be declared down this main function, like here where I'm writing this mmjjkk like that. Okay, some functions can be declared below this main function, below this main function. But compiler always assumes, compiler is a conventional tool that converts, that interprets or converts your code to uh, C++ to the binary language, right? Okay. Compiler always assumes that your functions are always written above the main function. There is nothing below the main function. Compiler has this kind of mindset that main function is the last function of every program. Below it, nothing can be there. Nothing can be there below it. But you know that you can write this function down. Okay, you can write this function down. Suppose I'm copy pasting it and I'm writing this function as down. Okay, I'm writing this function down. Now your compiler, let us run this code and see what compiler will say about this. Okay, oh, addition. Okay, addition, yeah. See the error message, see the error message, the blue background. Addition was not declared in the scope. When compiler checks this code, it says addition was not declared. Not declared means you have called this addition function, but it is not declared. Compiler is saying like that, but you know that it is declared. You know it is declared, and compiler is saying that it is not declared. What is the issue? Can anyone identify like what is the issue? As I already told you that compiler always assumes that every function is written on the top of the main. But this time we have played a trick with compiler and written the function down. How you will make sure that compiler should know that some function is down the main? Okay. You want your compiler to know that there is some function declaration that is below this main function. So what you can do in this case, you can give the prototyping. Simply copy paste this, or simply write, I am writing this, int addition int a comma int b. Simply write that. Okay, complete your function or make your function below main, but give a hint to compiler. This is known as giving a hint. Just copy paste this line and write it here above, so that your compiler, when your compiler will read the code from line number 1, it will, when it will came across this line 5, it will see, okay, addition function is defined, it means it is somewhere present in your code. Okay, then compiler will not assume that there is not any addition function. Compiler will gets a guarantee by doing this that there is some addition function somewhere in the code. Okay, so it will consider this. Let us run this code and see what will happen. Let us run this code and see what will happen. Ooh, it is giving us 30. Can you see, like, it is giving us 30. Earlier it was showing us error that addition function is not declared. But it is showing 30 now. It is showing the correct answer. But again, if I'll delete this line and run this code, let us see what compiler will think. Oh, it is again showing addition function was not declared. It means again we have not given any hint to compiler that our function is created. How compiler will know? Okay, but when you define this, declare this function above, when you declare this function above, it will, okay, by writing this line, now it will get a hint. Compiler will get to know, okay, the programmer have written this addition function somewhere in the document. Somewhere in the document this function is written, constructed, created, made, right? That, okay, then compiler will identify this or find this. Compiler will find this function declared or defined, constructed below the main. Otherwise it assumes that every function will be on the top of the main, but now you have written the function on the down the main, below the main. Then how will compiler identify? This is the hint you will give to compiler on line number 5. This is the hint. By this line, compiler will get a hint that for sure there is a addition function in the entire document, and compiler will automatically locate that addition function and execute it. Automatically it will automatically locate this addition function and execute this. So this is all about function prototyping. Okay, it is a very popular technique. It makes the code more stylish and readable. Okay, this is all about this session. I wish you all the best. Thank you.